Hi everyone, welcome to Calc Lesson number 58. Today we are going to continue with u substitution, but we are going to be looking specifically at what happens when those other variables like our x's or our t's don't cancel. So before we jump in, let's get started with a quick warm-up problem. We want to integrate the square root of 2x minus 1 dx. We know we want to start by rewriting this as the integral of 2x minus 1 to the 1/2 power dx. I'm going to choose my inside function of 2x minus 1 as my u, which makes my du just equal to 2 dx. And then solving for dx, we get dx equals du over 2. Rewriting my integral in terms of u, I have the integral of u to the 1/2, replacing dx with du over 2. I recognize this over 2 as a constant that I can bring out to the front. So I can write this as 1/2 times the integral of u to the 1/2 du. Now I can just integrate as normally, so keeping my 1/2 on the outside, this becomes u to the 3/2 divided by 3/2 or multiplied by 2/3, and then my 2's are going to cancel, which leaves me with 1/3. I'm going to replace my u with 2x minus 1 to the 3/2, and since this is an indefinite integral, I need my plus c. So just a quick little warm-up to get your brain back into integration mode. Okay, so we are going to look at our first example. We want to integrate x times the square root of 2x minus 1 dx. So just like always, I'm going to start by rewriting. I know that I can't handle that square root, so I'm going to make it x times 2x minus 1 to the 1/2 power dx. Just like I did in my warm-up, I'm going to identify my inside function as u. So I'm going to let u equal 2x minus 1. Just like in my warm-up, du is going to equal 2 dx, which means dx equals du over 2. Good news so far. So I'm going to go ahead and rewrite my integral just like I would in my warm-up problem. So I have the integral of x. I'm going to replace my u to the 1/2 power, and I'm going to replace dx with du over 2. Now, up until this point, any leftover variable that you had in your integral that was not a u had canceled. However, now we come across this issue where we have a leftover x and nothing that it cancels with. So this is where we have to actually change our x to be in terms of u. So we are going to go back up to where we wrote our equation for u. And we are going to solve this equation for x. So if we have u equals 2x minus 1, then u plus 1 equals 2x. So u plus 1 over 2 is just equal to x. So just to reiterate, we went back to our original, the equation that we chose for u, and we decided to solve for x. So we moved it around and we got x equals u plus 1 over 2. So now I'm going to go back to my integration step and I'm going to rewrite my integral again, but this time I'm going to replace x with u plus 1 over 2, and then I still have u to the 1/2 du over 2. So now what I have is an integral that is completely in terms of u. It's just a little bit messy. So I'm going to try to simplify this before we do any actual integration. So let's start by recognizing that we have a 2 in our denominator here and a 2 in our denominator here. So let's combine them and make them a 1/4. And then we're left with u plus 1 times u to the 1/2 du. So now I'm going to factor that 1/4 out to the front and then distribute the 1/2. So this becomes a 1/4 on the outside. The integral of distributing my u to the 1/2, u to the 1/2 times u to the first would be u to the 3/2, plus u to the 1/2 times 1 would just be u to the 1/2, and then I still have my du. So now I have an integral that is completely in terms of u and a little bit easier for me to integrate. So now that we've created where we just have u to a power, we can go ahead and integrate as normal. So let's keep our 1/4 on the outside. Integrating u to the 3/2, we get u to the 1 higher power, which would be 5/2, and then divided by 5/2 or multiplied by 2/5, plus when we integrate u to the 1/2, we get u to the 1 higher power, which would be u to the 3/2, times or divided by 3/2 or multiplied by 2/3. Now we just want to clean this up a little bit before we are finished. So let's go ahead and let's distribute that 1/4 through. So this becomes 2/20 u to the 5/2 plus 2/12 u to the 3/2. So let's go ahead and simplify. 2/20 we can write as 1/10. With an indefinite integral, we need to replace our u back with our x. So let's make this 2x minus 1 to the 5/2 plus 2/12 is just 1/6. Replace our u with 2x minus 1 to the 3/2. And again, because this is an indefinite integral, let's not forget about that plus c. So just a quick recap for you guys. We started integrating this the way we have integrated with u substitution throughout this entire chapter. However, we came to a part where our x or whatever variable that's not a u did not cancel. So we had to go ahead, rewrite our u in terms of x, or rewrite our x in terms of u, replace it into our integration, and then we could continue from there. So take a second, pause the video if you need to. Make sure you get any questions answered on this one before we move into any that are more complicated. Okay, we're going to jump right into example 2, and you might be noticing example 2 has a little bit extra in that we now have a definite integral, so we're going to have to handle our upper limit and our lower limit in addition to all of the steps that we took last time. So let's start, just like we always would, by rewriting this so that we don't have a denominator and we don't have a radical. So I would prefer to think about this as the integral from 1 to 5 of x times 2x minus 1 to the negative 1/2 power dx. From here, I'm going to go ahead and choose a u value just like I always would. I'm choosing my u as the inside piece, so u equals 2x minus 1, which makes du equal to 2 dx, and dx equal to du over 2. So now I'm going to go ahead and continue just like I always would and see what happens. So I'm going to start to fill in my integral. I'm going to keep my x. I'm going to replace my u to the negative 1/2 power, and I'm going to replace du over 2. Let's also go ahead and change our upper limit and our lower limit. So let's change when x equals 5 using our u equation. U would be equal to 2 times 5 minus 1, which would just be 9. And when x equals our lower limit of 1, u would be equal to, using our equation, 2 times 1 is 2, minus 1 is just 1. So changing our bounds to be from 1 to 9, or our upper and lower limit. Notice, just like in the last example, our x does not cancel, so we have to go ahead and rewrite our x using our equation for u. So if u equals 2x minus 1, then u plus 1 equals 2x. So u plus 1 over 2 equals x. And that is not always the case. That is just the case for these few examples. So let's go ahead, rewriting our integral, replacing this x with what we just solved for. We can write this as the integral from 1 to 9 of u plus 1 over 2 times u to the negative 1/2 times du over 2. So it's getting a bit complex. We're going to kind of follow the same steps we took last time, starting by taking these 2's and multiplying them and bringing them out to the front. So this becomes the integral from 1 to 9 of 1/4, And then we have u plus 1 times u to the negative 1/2 du. And before we can integrate, let's just distribute our u to the negative 1/2. And I'm actually going to bring my 1/4 out front. So it's still the integral from 1 to 9. U to the negative 1/2 times this would be u to the first. If we add them, we get u to the 1/2 power plus u to the negative 1/2 times 1 is just u to the negative 1/2 du. Okay, finally, after all of that work, we are at a place where we now have an integral completely in terms of u, including our upper and lower limit, and now we can go ahead and integrate as usual. So keeping our 1/4 on the outside, u to the 1/2, when we integrate, we get u to the 1 higher power, which would be u to the 3/2 divided by 3/2 or multiplied by 2/3, plus u to the negative 1/2, take it to the 1 higher power, becomes u to the 1/2, and then divide by 1/2 or multiply by 2. And then we are, of course, going to be evaluating this from 1 to 9. Now I'm going to first distribute my 4 through, so this becomes 2 over 12 u to the 3/2 plus 2 over 4 u to the 1/2, and I'm actually going to go ahead and simplify both of those. So 2 over 12 I'm going to rewrite as 1 over 6, and then 2 over 4 I'm going to rewrite as 1/2. If that was a little fast, feel free to pause or to back it up a little bit and make sure that you are okay with that. Now I'm going to evaluate from 1 to 9. So we can go ahead and plug in. This becomes 1/6. So let me hold up. Let me go down so I have a little bit of a bigger space here. If we're plugging in a 9, we would get 1/6 times 9 to the 3/2 plus 1/2 times 9 to the 1/2. And that is all just evaluating at 9. And then we want to subtract if we plug in a 1. So that would give us 1/6 times 1 to the 3/2 plus 1/2 times 1 to the 1/2. And again, that's all plugging in our lower limit of 1. Now we have a bit of simplifying to do. 9 to the 3/2 would be the square root of 9 is 3, cubed is 27 over 6, plus 3/2, and that again is just from my upper limit, minus 1/6 plus 1/2, from my lower limit, so if we give everything a denominator of 6, I am running out of room here, sorry guys, this becomes 27 over 6 plus 9 over 6 minus 1 over 6 plus 3 over 6 gives me 27 plus 9 is 36 over 6 minus 4 over 6 gives me 32 over 6, or a final answer of 16 over 3. And if you used a calculator for all of that, that is totally fine also. So just a recap, the same steps with the added bonus of getting to change our upper and lower limits from x over to u, and then continuing using definite integration the way that we know how. And again, if you have any questions, you can pause the video, go back, watch it again and again, or ask your teacher. So at this point, you guys know the steps, you've tried a couple, but practice really will make perfect. So feel free to pause the video, write down this problem, try it on your own, and then come back to check or to get some tips. Okay, I'm assuming you paused and you tried it and now you are back. So let's go ahead and go through and see if we did the same thing. So I'm hoping that, like me, you recognize the square root as something that we are not going to be working with. So let's rewrite this as the integral of x times x plus 6 to the 1/2 power dx. And then from here, we're going to choose a u. So I'm going to choose this inside piece. And I'm going to let, oops, not in highlighter. I'm going to let u equal x plus 6, which means du is equal to 1 dx. So dx is just equal to du. So I'm going to go ahead and rewrite my integral, keeping my x and replacing this with u to the 1/2 power and just replacing dx with du. Unfortunately, I still have an x that had nowhere to cancel, so I go back up to my equation for u and I solve. If u equals x plus 6, then u minus 6 is equal to x. So I'm going to go ahead and replace that. So let's write this as the integral, replacing my x with u minus 6 times u to the 1/2 du. Now I can't integrate this, I need to simplify first, so let's distribute our u to the 1/2 through. So this becomes the integral of u to the first times u to the 1/2 gives me u to the 3/2 minus 6 times u to the 1/2 du. And now that I have just u's and exponents, I can go ahead and integrate as normally. So integrating u to the 3/2 gives me u to the 1 higher power, so u to the 5/2 divided by 5/2 or multiplied by 2/5. I'm going to subtract, keeping my 6 on the outside. When I take the antiderivative of u to the 1/2, I get u to the 1 higher power, which would be 3/2, and then divide by 3/2 or multiply by 2/3. I'm going to simplify this to be 2/5 u to the 5/2 minus 6 over 3 is just 2 times 2 gives me 4 u to the, 3/2. Now this is a bit messy, so I'm going to write these with a common denominator and see if I can simplify a little bit more. So let's make this 2/5 u to the 5/2 minus, let's write 4 as 25 u to the 3/2. Now I'm going to go ahead and I'm going to factor out my greatest common factor. And looking at these two pieces, my greatest common factor is actually going to be 2/5 u to the 3/2. So if we factor that out, 2/5 u to the 3/2, we are left with, in our first term, we're really just dividing by u to the 3/2, so we're just left with u. And then we are left with, if we take 2/5 out of 25, we're really thinking 2/5 times what gives us 25, and that would be a 10, and actually a negative 10 since we are subtracting, and we took the whole u to the 3/2. So again, this is just taking out that GCF. If you don't understand, take a second, pause, watch it again, ask your teacher, make sure you can get to this point. From here, I'm going to go ahead and replace back with x. So this becomes 2/5, replacing with x plus 6 to the 3/2 times, replacing my u with x plus 6 minus 10. I can combine a positive 6 and a negative 10. And my final answer is going to be 2/5 x plus 6 to the 3/2 times x minus 4. And then because this is a general solution or an indefinite integral, I can't forget my plus c. So when you guys tried this on your own, hopefully you got pretty far, at least up to this step. And then if some of that GCF factoring stuff didn't come quite naturally, that is okay. Again, like I said before, practice will make perfect. Awesome job with these problems today. Homework 58 is actually just going to be these 1, 2, 3 problems, and I included hints for numbers 2 and 3. So go ahead, take a picture, write these down, make sure you have these. This is going to be homework 58. And then as always, if you have any questions, please feel free to reach out to your teacher.